In this lecture, we're going to learn about the string view type. This is a type that is going to allow us to save memory, especially if we are trying to use a string literal to initialize an std string like we see here. If you look here, you see that we have three string variables. One is initialized with a string literal, which is saying hello, and the other two are initialized using the first std string variable that we have. And from the last lecture, we saw that these two guys are just going to be completely new copies of this string, and they are going to live in different memory locations. And this was a waste. std string view gives us a way out of this waste. If we change our code to be something like this, you see we are saying std string view instead of saying std string. We will be viewing this string literal wherever it is in memory without copying it, as we did when we used std string. And this is going to save us some memory. If you go down here, you see that we try and get the size of this string view object. We're going to see how big it is when we hit Visual Studio Code. But for now, let's go down and see how we can print this. You see that you can use it exactly like you've been using std string, but these two guys, sv1 and sv2, are not setting up completely new copies of the string hello that live in a different memory locations. So we are just using the memory where the string literal hello here is saved. Okay, so string view is a type that allows you to view data in another string that lives somewhere, and it doesn't even copy the string literal when you initialize that with a string literal like this. Another thing you should know is that there are a gazillion ways you can initialize your string view. Here we have a few examples. We have the data on top. We have an std string. We have a const char pointer, which is initialized with a string literal. We have a character array initialized with a string literal. And we have a character array, which is not null terminated. We can build string views from all these guys here. As you see here, sv3 is using a string literal, sv4 is using another std string, sv5 is using a c string. It is what we say in the initializers here, and this is going to work pretty well. If you go down here on sv7, you see that we can even initialize a string view with another string view. We can even use a non-null terminated character array, but when we do things like this, we have to pass in the size of the character array, and we can print these string views like we print anything else, and you're going to see that it is going to work. One thing you should really be careful about is that it is not recommended to use non-null terminated character arrays. Here I am just mentioning them for completeness, but in practice, you should really avoid these guys. They are going to get you into trouble. Another thing I want you to know is that if you set up a string view, viewing some string in memory, and you change that string later, the changes to that string are going to be transparent to the string view. They are going to be visible from the string view. And here is a simple example to drive the point home. We have world, which is a character array. We have a string view, which is going to view that. And if later we change world at index 2 to be a t, and change dog to say dot, and we try to print the string view, we're going to see the changes reflected in the string view. And if we print it now, like we do here, we're going to have dot printed on the console. Another thing you should know is that a string view is really like a tiny window through which you are watching the string. And C++ allows us to shrink the range of that window. So here we have a string that says the animals have left the region. We can shrink this window starting from the left, something like this. We can take out the T, we take out the H, we take out the E, and we're going to be left with a string that says animals have left the region. We can also shrink the window starting from the right. And we can take out the N, we can take out the O, and keep going until we hit the last T here, and we can remove it, and we can be left with this thing. So one thing you should know is that these changes we do through the view don't affect the original string. And again, a string view is a simple type through which we can watch another string, but if we shrink the window of the view, we won't be affecting the original string. You have to keep this in mind. And here is how we can do this in code. We have a C string which says the animals have left the region. We set up a string view sv10 to view that C string. And we can shrink the window from the front by using the syntax like this. We can say sv10 remove, and we specify how many characters we want removed. We want to remove 4 characters. So what this is going to do is to remove the first 4 characters, including the space here. Okay, if we go down, you see we also have a version to remove suffix. This is going to remove from the back of the string, and we're going to remove 10 characters. And if you count, you're going to see that we're going to remove these guys here. And we're going to be left with animals have left. Another thing you should keep in mind is that a string view cannot outlive the string it is viewing. Here is a simple example to drive this home. We have a string view which lives in the global scope, for example, in the main function. And we have a nested scope set up here. If we go inside, we set up a string. We set up the string view to view that string through the syntax here. We take the string and assign that to our string view. And from this moment on, the string view is going to be viewing string 4 here. We can print things out. We say SV11 is viewing whatever it is viewing. But when we go out of this scope at this point here, then the string has died, but the string view is still alive because the string view was declared on top here. So from this point on, if you try to use the string view to do something, you're going to be basically setting yourself up for a disaster because the string view is not viewing valid data. So you might be affecting data that belongs to other people, and anything can really happen. Sometimes this code is going to run and try to lie to you that nothing is wrong, but chances are if you run this program, you're going to be modifying memory that doesn't belong to you, and that might lead to crashes, corrupting memory that belongs to other people. It's basically bad. You shouldn't do it. So make sure that your string view doesn't outlive the data it is actually viewing. String views also have the data method we can use to view the character array inside that we are viewing. And we can use this data behavior if we need to get access to that character array. So for example, here you see we are printing our string view, and we can use stdstrlen to get to the length of our string, and this is going to work. But sometimes things can go wrong if you try to use the data method. If you try to use the data method from a string view that has been modified through the remove prefix and remove suffix behaviors, you're going to be setting yourself up for trouble because this is really not supported for string views. The data you get is not going to be consistent. For example, if you go down here, you see we are printing what is viewed through the data method. We're going to have something. And if we try to print through the data, we're going to get something. And if we print the string view itself, we're going to get something else. So the data is not going to be consistent. And don't do something like this. If you know that your view has been modified, don't use the data behavior on it. That's the message here. Another thing you should really avoid is to view non-null terminated strings. If you set up code like this, it is going to work, it is going to compile. But if you try to use this in your application, you may get inconsistent behavior. So don't do this. The reason is, if you try to process a non-null terminated string, whatever is processing our character array is going to keep going until it sees a null terminator. And that might be 10 characters ahead, 20 characters ahead. You're basically going to be navigating memory that doesn't belong to you, and bad things can happen. So don't use non-null terminated strings in your code. The last thing I want you to know is that string views have many of the behaviors we have on stdstring. For example, we have the length behavior, we have the front, back. We can get a substring of a string view. We can really do all kinds of crazy things with this type. But the main thing is that it's going to be viewing the data. It's not going to copy the data, and we're going to save on memory by using string views, especially when we have to initialize things with string literals. This is going to come in very handy. This is really all I have to share in terms of std string view. We're going to head over to Visual Studio Code and play with us. Here we are in our working folder. The current project is string view. We are going to grab our template files as we always do. We are going to put them in place and we are going to open this in Visual Studio Code. We are going to include string view. Let's do that. We're going to include the string view library. You see that it is recognized by Visual Studio Code here. And we are going to go down and set up our first example here. We have three string variables, I should say stdstring, and the first one is initialized with a string literal. And the second one is initialized with this string here. Same thing for the third one. And we're going to try and print the addresses of these guys in memory. And let's build and see what we get. We can close this left pane here. We don't need it anymore. We are going to build with GCC. Let's do that. The build is going to be good. We can set up a new terminal and we are going to clear and run rooster. You see that the first one lives at this address ending in DB0, the second one DB90, the third one at D70. So these three guys live at different memory locations, and this is one way we can prove that they live at different memory locations. And the second guy here is a copy of the string. So it's a completely new string that have been set up somewhere else in memory, and we just copied the data over. The third one here is also a copy, and we set it up somewhere in memory. We set up a string large enough to hold hello, and we just copied each character from the source string here to these new strings. And you can see that we are really wasting memory, especially if what we are interested in is just printing this text here. And another thing that is really a waste is that this string literal is already living somewhere in the memory map of our program. So it is already eating up memory, but we just use this string literal to initialize another string that is going to live somewhere in memory. I have to apologize, I don't have a way to really show you where this string literal is living, but you can trust me that it is going to be already living somewhere, and we just copy the data over from that location to even initialize the first string here. So this is really a waste. We don't want to copy data, and string views help in doing that. So let's say what we are doing here, showing the problem, and we're going to comment this out and show a string view version of this. We are going to go down here and put in our code we want to use, and we're going to say that we want to use string views. And what we're going to do is use stdstring view instead of using stdstring like we did before on top here. And what this is going to do, it's going to set up a tiny object, or a tiny type, I should say, that is going to be viewing this hello string literal wherever it is living in memory. We're not going to be completely setting up new strings and copying data. And the real benefit of this is that if the strings happen to be really large, say for example it has 1,000 characters inside, we're not going to be copying all this data over. All these string views, including SV here, are just going to be viewing the original data. And they are going to give us a handle through which we can go and view the data and print it out if we want, but we won't be setting up complete new copies of the string here. So down here you see we are trying to get the size of this object and see how big it is in memory. We can even go down here and say size of SV1. And down here you see that we can go through the string views to print and view the data in here. And this is really cool. So let's try and build with GCC and see that the compiler is happy with this. It is going to be happy. The build is good. We can clear and run rooster. And you're going to see that SV, SV1, SV2 are going to contain the same text. And the size of a string view is 16 bytes in memory. Let's try and shrink this down and see that the size changes. Let's say hello here. And we're going to build with GCC. And if we clear and run rooster, you see that the string view, the size of the string view doesn't change. And this is really cool. This is a tiny object. 16 bytes is really nothing in memory compared to the fact that we can use this to view a string that is 1,000 bytes or even 10,000 bytes. Let's try and really make this large. and come back and try to build again. You have to really play with us and see if you can break things. This is the best way to learn. We can clear and run rooster. And you're going to see it doesn't really change. The size is the same, but we can view potentially really large strings. And this is really cool. And this is not going to copy the entire string that we have here. This is just going to be a tiny variable in memory that is going to allow us to view the data in the original string literal here. I really hope this makes sense. So we're going to go down and comment this out. And we are going to go down here and show you different ways you can construct or set up your string views. Okay, let's go down and put in our code here. And again, if you want to get the code, you can check the resource section of this lecture. You're going to find the source code attached for this lecture. But I really do recommend typing these things out. But I'm not going to type all this because I would be just wasting your time watching me type these things. So we have string 3, which is a regular std string initialized with a C string here. We have a regular C string, which is a car pointer. We have a character array initialized with a C string. And we have a non-null terminated character array here. We can set up string views to view all these guys here. For example, SV3 is going to be viewing a string literal, SV4 is going to be viewing an std string, SV5 is going to be viewing our C string here, SV6 is going to be viewing the character array, which is null terminated, SV7 is going to be viewing another string view. We can even do that. And we can set up a string view to view a non-null terminated character array. And this is bad. You shouldn't be doing this, but I am showing you this for completeness here. So once we have these guys set up, we can go down and print them out. Let's build with GCC. We're going to choose GCC here. You're going to see that the build is really good. So we can clear and run rooster. And you're going to see that we have the data from SV3 all the way to SV7 like we have here. And we even have our non-null terminated string printed through the string view that is viewing it. And this is really cool. But you shouldn't really be using things like this. And again, I mentioned this for completeness, but you don't really want to do this in practice because that's just going to be a recipe for disaster. Again, whatever is processing your string might go over bounds hunting for the null terminator. And once it finds it, it's going to stop processing the string. But by that time, you will have gone over bounds and gone beyond the legal boundaries of your array. And you will be modifying memory that belongs to other people. And that's bad. And in extreme cases, your program is going to be terminated by the operating system. The operating system is going to say, this program is crazy. I don't know what it's doing. I am going to kill it. And your program is going to crash. So this is something you should really avoid. And again, don't use non-null terminated character arrays in your programs. But here you see that we are using a string view to really view any kind of string we can have in our C++ program. And this is really cool. We can go down and show you that changes to the original string are reflected in the string view that is viewing that string. We can go down and put in a simple example to show this. We have a character array, which is initialized with dog here. And we set up a string view, which is going to view that. We can print this guy through the string view and then change the data and print the data again. So what we expect to see is dog here. We're going to see changing data and we're going to see dot printed out because we changed the original string, but the string view is going to pick up those changes and print those out here with SV9. So we're going to build with GCC. Let's clear. The build is good. And run rooster. You see we have dog and dot. This is exactly what we want to see because we have changed the string, but the string view we set up beforehand is going to pick those changes up and show them up if we happen to print after we change the data here. And this is really cool. And I want you to be aware of this. The next thing we're going to see is that we can change the view window to really shrink it. We can't change by expanding. We can only change by shrinking. And here is a piece of code to play with us. We have a const character array which is initialized with the animals have left the region. And we have a string view which is going to view this string, whatever it is in memory. So what this is going to do, we're going to be able to view and manipulate things through SV10. So if we print through SV10, we're going to get the original string because we haven't changed anything yet. But if we do SV10 remove prefix and specify that we want to remove 4 characters, that's going to basically be like a window sitting on top of this string, hiding the first 4 characters. That's what this is going to do. And we can also remove the suffix. And what that's going to do is to remove however many characters we want to hide through the string view here. And one thing you should know is that this is not going to be changing the original string. This is going to just change the view. And if you try to access the data through the original C string variable here, you're going to get whatever data was in there. You're going to get the entire thing here. So let's try and build this and see if it actually works. We're going to build with GCC. The build is good. You can clear and run rooster. We're going to see SV10. This is the original string here. We are going to view with removed prefix, and you see that we say animals have left the region. We have removed the first 4 characters through the view here, and that's going to remove even the space here. And the last thing we print out is original SV10 viewed string. And you see that we see the entire thing printed out here. So these 2 behaviors from stdstring view allow you to change the size of the window you are using to view the original string. I really hope this makes sense. The next thing I want you to be aware of is that it is really not recommended to make your string views outlive whatever it is they are viewing. And here we're going to put in a simple example to show you that we have a string view SV11. And after that, we set up a nested scope, which is going to be in here. And inside, we're going to set up a string 4. It's going to contain hello there. And we use this string view that we set up on the outside here to view the string here, which is set up on the inside. So what we're going to achieve with this setup is that when we hit the last curly brace here, the string is going to be out of scope, but the string view will still be viewing it. So it will be basically viewing something that is already dead from the perspective of our program. And the memory where this string lived might be used by another program, who knows? And if you try to use that, you might even get a crash. One thing you should know is that you shouldn't try to print things like this. If you do this, it will compile, but what the string view is viewing might not be what you think it is viewing, because the data that it was viewing is already dead. So if you do this, it might work. It might print the string here if it is still around, but if it's not, you might get complete garbage, or you might even get a crash if you are trying to access a really important piece of memory on your operating system. So don't do this. Let's try and see what we get. Okay, the build is good. If we clear, let's really differentiate these 2 guys. So here we're going to say inside, and here we're going to say outside. Okay, this is going to be easier to follow. Let's build again to take those changes in, and we're going to clear and run rooster. You see, inside we say hello there. Outside we say hello there. It is still printing this guy, but we're not guaranteed to get this behavior every time we run our program. This is really bad because the memory where this string lives is already dead, and we are trying to view it after it is dead. So this is a recipe for disaster. Don't do it. The message here is string views shouldn't outlive whatever they are viewing, because if you do that, the string view is going to be accessing illegal memory. The next thing I want you to see is that we can use the data method like we use that on stdstring. Let's type data. And I am going to put in a simple example to drive the point home. Here we have a string view which is viewing a string literal containing the message ticket. And we can print that out through the string view. This is going to work. But we can even call the data behavior on our string view here. The reason we have this squiggly line is that we don't have the facility to work with strlen, let's include that. If you remember, it is C string. So we're going to bring this in. And if we go down, the squiggly line should go away. In a minute, it's gone. Now we can build this and see what we get. We're going to use GCC. And if we clear and run rooster, we're going to see that we printed the ticket here. And the length is 6 because we have 6 characters in here. But the data method doesn't always work with string views. Sometimes you might get weird behavior. And you shouldn't really use the data method from stdstring view if you happen to have modified your string view through the remove suffix and remove prefix behaviors here. I am going to show you why. Let's go down and put in a piece of code for you to play with. We have a string view which is going to be viewing our ticket text. And in front, we're going to remove 2 characters. So we're going to remove TI here. And from the back, we're going to remove 2 characters. And we're going to remove ET here. So let's see what we get here if we print the length of the string through the data method. We're going to try and print this guy through the data method. And we're going to print through the string view itself and see what we get. We are going to build with GCC. And the build is going to be good. We can clear and run rooster. And the first thing is going to say SV14, which is CK here. We have shrunk the window through which we are viewing through the view. So we're going to be viewing CK here. This is right. But you see that it says it has 4 characters. So SV14 here is telling us we have 2 characters in here because we see CK. But if we go through strlen, we see that we have 4 characters inside. So which one is which? And this is really not right because we shouldn't really have 2 characters inside. But you see that the information we get from these guys is really not consistent. The reason is stdstring view wasn't designed to use the data method when you have modified your string view through the remove prefix and suffix behaviors here. So don't do that. Otherwise, you're going to be getting weird errors when you try to use the data method to get information about your string. I generally would advise you to even not go through the data method to do things because you set up a string view because you want to go through it to manage things in the first place. So don't try to use the data method. And even if your specific use case forces you to use the data method, make sure you don't use it with these 2 methods that modify the viewing window of your string view because that's going to give you problems and this can be really hard to debug in real code. So don't really do this. Another thing you shouldn't do is viewing non-null terminated strings through string views. Let's go down and put in an example. We have a character array. It is non-null terminated. And we view that through SV15 here, which is a string view. And we saw that the syntax to do this, you pass the character array and you specify the size. We can do this. But if we try to get information about these guys, again, we're going to get inconsistent behavior because whatever is viewing the character array here is not going to stop at this O here. It's going to keep going until it sees a null terminator. And that null terminator might live in a piece of memory that doesn't belong to us. And this is really bad. Don't do this. Let's try and build this. We're going to use GCC again. And we're going to clear and run rooster. You see that we say hello has 5 characters. SV data is hello. You see that we seem to get consistent behavior. But this is not guaranteed to be always the case because the string here might keep going until we see a null terminator, and that null terminator is already living in space that doesn't belong to us. If you remember, when we looked at arrays, we thought that this array is going to be initialized to contain 5 characters here, and if we go overbound and step out of those characters, we're going to be accessing memory that doesn't belong to us. And at this moment, you should really know that that's not something that is going to be good for your program. So don't do this. The last thing I want you to see is that we have a few methods that we are familiar with from stdstrings, and we can use them with stdstring view as well. And if we go down here, we're going to put in a simple example. We have a string view, which is going to be viewing this guy here. We can use the length behavior. We can use the front, back, and we can use str to get a substring of this little guy. We can really do all kinds of crazy things. I will leave you to go and check the documentation for stdstring view and see however many behaviors you can use on this guy. For now, we're going to just be happy with what we have here. So we're going to build with GCC, and we can clear and run rooster. We're going to see that we're going to get this information here. SV16 is 35 characters long. If you count these guys, you're going to get 35 characters. The front character is T, the back character is A. Substring is there is a huge forest. You can really do all kinds of crazy things if you happen to need these in your application. And this brings us to the end of this lecture. This is really all I had to share with you guys. Use string view to really save on unnecessary copies if you are using a lot of strings in your application. We are going to stop here in this lecture. In the next one, we're going to try and recap what we saw in this chapter. Go ahead and finish up here and meet me there.